So hello everyone, welcome to my new video. Today we discuss about the most popular question infix to postfix, how to convert infix string to postfix. So this is the popular question due to this is asked in many interviews and many companies. So let's start with the so first of all we understand what is infix string and what is postfix string. So the infix string is the contain these normal brackets and from A to Z alphabet and the five operator, which is one is power operator, second is our multiply operator, third is our divide operator, fourth is plus operator, and fifth is subtraction operation. So if like these items present in any string, the mix up of these elements, or you can say these items, is called the infix string. Okay. So now what is postfix? Postfix, when we apply some rule on infix string, apply some rules on infix string. So this is converted into something new string which is called postfix string. So I hope the infix string and postfix string now clear what is this. So now come on the implementation part. How to implement and what is the rule we have to follow. So let me erase this. So now come. So this is the one string is given. This is the S string is given. This is our infix string. You can see there is alphabets, there is some operators, there is some brackets. So this is infix string. We need to convert into this into postfix string. So we have to follow the certain rules. What is the rules? So I write like the first rule: if you see any any alphabet, so directly add to postfix string. This is the first step we have to follow. Okay, so this is the first step. Now come on second step. First we write step, then go on implementation part. So now come on the second step. Second step is if any opening bracket found, open bracket like this is opening bracket. If any opening bracket found, then push into stack. Okay, let's come on third step. Third step is to if any close bracket found, close means this bracket, if this is found, so while we do not get open bracket in top of stack, we will pop from stack. This is our third rule. So now come on the fourth rule. First we write, then we understand what is the rule says. So fourth rule is the if any operator found, then check that in the top of stack the preference of our operator is less or the equal to the difference of top of stack, so we pop from stack. So these four certain rules we have to follow and we get our postfix string. So this is the four steps. So now come on our string. Now we understand and we implement these rules. So let me start. So for this, first we have to need some stack. So I take one stack. This is my stack. Okay. So now come on the string. So I run a loop in my string. First I am at the A pointer. Okay. So I explain the first that if you see any alphabet, so directly add to, not top, add to postfix string. So come on this. Now we can see that A is alphabet. So I take one postfix string I take one postfix string. I can return as a text. I take one postfix string. So now A adds in our string. Okay, because A is alphabet, so no reaction with alphabet. Now come on the second part. Second is our operator. So what I say, if our operator is come, then check that what is present in stack, in top of the stack. There is no element in stack, so directly we append the plus in stack. Okay, so now come on B, again alphabet come, we add in our postfix string, so we add this. Okay, so now come on operator. Now when operator is come, what we have to do, we have to check the top of stack. So there our top of stack is plus, the preference of plus and minus is equal. Why we get, when we get our preference, so the preference order is this: the power operator have greater preference, then star operator, then star operator and our division operator is same preference, then plus operator and minus operator is same preference. Okay, so that is the order of the preference. First power operator is big, then star and division is equal but less than power operator, and greater than plus minus operator, then plus and minus is both are equal. So this is the preference order. So the preference of minus and plus is equal, so I need to pop this plus. So I pop the plus from here and append in our postfix string, and append this minus in our stack, this minus in our stack. So let come on C. Now C is alphabet, so we need that we directly append this C to our this part. Now come on the plus. Now again operator comes, check the top of stack. If the preference is equal or less, then pop. So if preference is equal, so I pop minus and append my minus here. So I need to append my minus here, and we need to append plus in our stack. So okay, now come on the D. D is alphabet, so directly append in postfix string. Okay, now come on star. So now star operator have more preference than plus operator, so we directly append this. Okay, no pop operation. Now come on bracket. So when you see any open bracket, directly append on stack, no need to change the postfix string. Okay, so now come on the E part. Now E is alphabet, so we need to append in our postfix string. Now come on the minus. Now when operator is come, check our top of stack. Here top of stack is bracket. There is no connection between minus and bracket, so we append the minus here. Okay. Our pointer is at minus. Now minus appended. Our pointer at F. So now F is alphabet. So what we do? We append in our postfix string. Now come on the bracket. Now what I say, that if any close bracket is found, then while we do not get the open bracket in stack, we popped out the elements. So now I get close bracket, so I check that my stack top is open bracket. No, I pop this and append in this. Okay, so now I check that stack is top equal to open bracket. Yes, so I need to just pop this and not need to add the bracket in postfix string. Okay, here is one condition is that bracket is always balanced. There is no issue of unbalancing bracket. Okay, so now come on the divide. So now divide and star, divide and multiply is same preference. So what I do, I pop star from my stack and append star in this. Okay, so now come on the divide, and now divide append in this stack. Now divide append. So now come on G. G is alphabet, so alphabet is directly added to postfix string. Now come on the plus icon. Now you can see that our plus operator is lesser than the divide operator in precedence, or you can say preference. So now what I do, while I get this condition, I popped out element and add in postfix string. So now I pop, because I get plus, and plus is lesser precedence than divide operator, so I pop this and add this into our string. Sorry for this, I add this in our string. Now you can see that our minus of where we began, our plus operator and this plus is same preference. So in case of same preference, we also pop this and append here. Okay, so now this plus append, or you can say push in our stack. Now come on the up. Now our open bracket is found, directly add in stack. Now h is coming, so h is directly added to my string. Now star is coming, multiple operator is coming. So multiply, now you can see that in stack top there is bracket, so no relation between multiply operator and bracket, so we need to direct append, or you can say direct push. Now come on the open bracket, so now open bracket is coming, we directly append in our stack. Now I operator is coming, so we directly append in our postfix string. Now divide is coming, so there is no relation between divide and this open bracket, so I append divide in stack. This is my stack. So now come on the j, so j is alphabet, so directly append this. Now come on this close bracket, so when I find close bracket, what I say, while we do not get open bracket, pop out and add it. So this is pop and add here. Okay, so I will, so let me pop this and append here. Okay, so now we can get the open bracket, so we only erase this and no need to append the, sorry for this, no need to append in postfix string. Okay, so now come on the second. Now also we get close bracket, so while we do not get open bracket, we pop out and add in our stack. So star is popped from here and add in our postfix string, not stack. And now we get open bracket, so only pop out this. Now we can at the tail of our end, now there is no character, our this infix string is completely convert into postfix. After this, one extra step is check the stack, if any element, or sorry, if any operator is present in stack, so we add into the last of the postfix string. So here is plus is present, so I add plus in this and pop the plus from here. Now my stack is empty, so this is the my final answer of postfix string. So that's all about infix to postfix string. Now we can see the pseudo code for this problem. So let me write it. So first I write write a function infix to postfix. So here I write some pseudo code like this. First we create a stack. Create a stack. Now we take a answer string, or you can say we take a postfix string. This as a empty string. Now we run a loop. You can run loop for I in range, or you can say yes, for I in range, and we run a loop. Now what we do, we write here condition if our element equals to open bracket. If our element equal to open bracket, what need to do, we append push in stack. Else if check that if element equal to any character, we can say any alphabet, so what we do, just we append in our answer array, you can say we add in our answer array, answer plus the element, or you can write add element in answer. Now the next condition is if we get element as a close bracket, so what we do, we write here, what we write here, we write while our stack dot length, while stack dot length not equals to 0, and the top of stack is not equals to open bracket, what we do, stack dot pop, and before popping please add in the answer string, answer plus equals to, yeah, you can say add add pop in answer. Okay, so now come on the next part, which is if then after completing while loop, when the condition is false, this while loop is break and we get our open bracket, so we need to pop one time again. This is pop for removing the close bracket from stack or open bracket from stack. So now this condition will also come. Now come on last condition, if we get any operator. So if we get any operator, we need to create a function to check precedence. So I here create a function, define precedence, and in the function I give some character. Here what I write, if my character is power operator, then return like 100. Any value you can return so we can compare easily. Okay. And if char equals to star or char equals to divide, you can return like lesser than this any value. Okay. So I take 90. Now right here same condition, elif if char equals to plus or char equals to minus, what return 80, and otherwise and other this operator if any get, else return -1. So this is our precedence function which we have to create. So now here what we check, that while stack dot length not equals to 0 and the stack peak, the preference, the precedence of the top of stacks is is greater than or equals to precedence of my character which is coming. So what I do I do result, you can say answer plus element, and sorry, answer plus pop operator, then stack dot pop. So that's code, and after completing this for loop we have to return while our length of stack is not equals to, we just check that is in stack every element is present or not. If there is while length of stack not equal to 0, what we do, answer plus stack dot top and stack dot pop. So this is the major idea about code. This is our like pseudo code type one code I have written, so you can convert in which language you. So thanks, that's all about this question, infix to postfix.